Tell me your name and a little bit about yourself.
So my name is Edwin Hubble. I was born on November 20th in 1889 in Marshfield, Missouri. And initially I was trained to be a lawyer, but in 1914 I changed paths and started studying astronomy.
All right, give me a brief overview of your main project or accomplishment.
So I started studying the Andromeda Nebula in 1914, and at the start of my research, very little was known about nebulas and about the universe in general. Some people thought that nebulas were embryonic solar systems forming, while others thought that they were island universes similar to our Milky Way galaxy. Mainly through my own research and research done by Milton Humason, Henrietta Leavitt, and Vesto Silfer, I was able to give an estimate age for the universe and also develop the expanding universe theory.
So what was your role in the project?
My role was that I managed to relate all the information gathered by other astronomers along with the information that I found myself to explain better what a nebula was and exactly what they're doing inside of space.
So where did your research take place?
So I was using the largest telescope at the time. It was the 100-inch Hooker telescope on Mount Wilson in California. It's in Southern California, about 35 miles east of San Fernando.
Awesome. So what contributions were made by the previously mentioned other astronomers prior to your research that helped you initially?
In 1908, at the Harvard College Observatory, Henrietta Leavitt discovered Cepheid variable stars within a nebulae.
And what are Cepheid variables?
It's a star that is a period luminosity relationship. That means that the longer the period, the brighter the star was. I used the information that she gathered and applied it to Andromeda Nebula in 1924 after I calculated the period luminosity relationship for the Cepheid variables in Andromeda. I could calculate the distance to Andromeda, and it was about 900,000 light years from Earth. Vesto Silfer started studying the Doppler shift of spectral lines for spiraling nebulae, and by 1925, he had determined that most nebula exhibited redshift spectral lines. This told him that relative to us, the redshift exhibiting nebula were moving away from us, and some even at speeds of 1,100 kilometers per second. While he also noticed the blue shift of a few nebula. In those cases, the nebula were moving in a direction towards us. For example, Andromeda was measured moving towards us at a speed of 300 kilometers per second. And combining all the discoveries just mentioned, it was determined that spiraling nebulae are what was then called an island universe and now referred to as galaxies.
So what else did you find during your research?
So Milton Humason, he was later using a larger Hooker telescope to measure the amount of shift in spectral lines and compared those to arc lamp of the spectrograph to calculate the velocity of galaxies. He found a few galaxies with blue shift, meaning that they were coming towards Earth, but discovered most of them had red shift and were moving away. This allowed me to infer that the smaller the galaxy appeared in the telescope, the further away it was. Plotting the distance to velocity on a graph, I discovered what we now call the Hubble's constant. Having plotted the different galaxies based on velocity and distance, and a linear relationship between the points was found using the line of best fit. The slope of the said line is now known as Hubble's constant, and at the time was valued at 500 kilometers per 3.26 million light years per second. The graph showed that the further away the galaxy was from the Milky Way, the larger the velocity going away from us. What? Did that sound right? This was published in, I'm gonna redo that for that line. The graph showed us that the further away the galaxy was from the Milky Way, the larger the velocity was, it was moving away from us. This was published in 1929 as Hubble's law, which is velocity equals Hubble's constant times distance. And this suggested that the universe was expanding. It also means that at some point, the galaxies were much closer, and going even further back in time, that the entire universe must have been located at one point in space. Now, by taking the inverse of Hubble's constant, it can be used to evaluate the age of the universe, which was found to be about 2 billion years old.
So what other significant events were going on around the world at the time?
So World War One had just come to an end in 1918. In March 1927, Charles Lindbergh made his first solo transatlantic flight, and in October 1929 was when the stock market crashed.
And what impact did your project have on the physics community?
So my discoveries disagreed with other methods of dating the universe, and those methods dated it about 3 to 5 billion years old. This was resolved, though, in the 1950s by recalibrating the period luminosity value of Cepheids to give the universe a more accurate age of 10 to 20 billion years old. And today, scientists are working to get a more precise value for Hubble's constant, and have gotten it redefined to 70 kilometers per 3.26 million light years per second, plus or minus 10%.